Welcome to the Transum Podcast, a monthly roundup of the new features on the transum.org website, providing mathematical puzzles, games, learning activities, and the ever-popular mathematics lesson starter of the day. Here's your host, John Tranter.
Ohayou gozaimasu, sawadee krap, namaste, sastrigal, and welcome to this podcast number 128, which of course you know is the seventh power of 2, and it's for the month of July 2025, beginning as usual with the puzzle of the month.
A rectangle is drawn inside a right-angled triangle. One vertex of the rectangle coincides with the triangle's right angle. Another of the rectangle's vertices meets the triangle's hypotenuse. The rectangle is 34 millimeters from one of the acute angles and 25 millimeters from the other. What is the area of the rectangle?
That's the Transum puzzle for this month. The challenge is set. Have a think. Make a plan. Month to figure it out. Send in your solution as soon as you can.
Okay, well, it doesn't seem as though you have enough information, does it, to solve that puzzle? But in fact, you do. So I'd love to hear how you finally get round to figuring it out, or how your students solved it. Drop me an email to podcast@transum.org. That would be great. While you think about it, here are some of the key resources added to the Transum website during this last month. Stalactites is a quick two-player maths game in which pupils race to grow the longest stalactite by choosing numbered growths from a shared pool. Each turn belongs to the player whose stalactite is currently shorter. They keep adding numbers until they match or exceed their opponent's height, at which point play passes over to the other player. Now, because the lead can change hands at any moment, the game stays tense right up until the final moment when all the growths are used up. This is a fascinating game, so simple rules, but it's very difficult to predict who's going to win, and it's very difficult to figure out a strategy. So, if you haven't seen that yet, because it's been on the site for a couple of weeks, look up stalactites or go to the newsletter, transum.org/newsletter, where you'll find the links to all the things I'm talking about, including Angle Aim, which is a bit of a retro game, and it's intended to provide light relief after students have completed the 4 levels of estimating angles. So meteorites fall from the sky, and the idea is to quickly type in the angle between 1 and 180 to fire the cannon to shoot the meteorite before they hit the ground. Lots of fun, bit of light relief there.
The text version of this podcast can be found at transum.org/newsletter.
Polygon Profiles is a brand new visual aid that shines a spotlight on the properties of regular polygons. It's designed to be projected full screen on your whiteboard, and just another visual aid for your repertoire. I can't remember exactly what inspired me to create the semaphore quiz, but one Friday I found myself completely engrossed in programming rotating flags. The quiz has 11 levels, each with 6 questions, and the messages are sent a little faster as you progress through the levels. Now, I remember learning semaphore when I was a scout. In fact, a friend and I practiced in my parents' front room, and I'll never forget that the letter D is one of the flags directly up above your head. And as we were practicing this, I managed to shatter the light fitting in the middle of the room. So I'll never forget that D for damage, as we called it, sticks in my mind. But if you've never seen Semaphore, have a look at that. And not strictly mathematical, but it's a code, and the angles of the flags are interesting. And the great code breakers throughout history were brilliant mathematicians for a reason.
You can find Transum Mathematics at www.transum.org.
Last month I added a brand new level 5 to the area maze puzzles, which have always been very popular. So whether or not you can read Japanese, this will provide a suitable challenge for your high attainers. Building on the first 4 levels, it's sort of a sophisticated version of the diagrams. You have to calculate missing lengths using only whole number arithmetic. And it was inspired by the Japanese logic puzzle tradition. It demands careful reasoning and, I guess, deep understanding of the rectangle area formula. So have a look at that with your students. Level 1 is a very easy way to get started. Level 5 is quite challenging. Well, some of the questions are anyway. Okay, some notable dates coming up in July. The 2nd of July is World UFO Day, believe it or not. I've put a link in the newsletter for each of these days so that you can do a related activity if you wish. The 4th of July is American Independence Day, and I've got that clock challenge for them to work out the digits that go on a clock using only 4s. 11th of July is World Population Day. This is a fascinating starter for this day where you can see the population of the world increasing right in front of your very eyes, and you as the teacher get a choice of lots of different questions you can ask about this big number. 14th of July is my birthday, and I've collected together some birthday mathematical resources that you can have a look at. And the 24th of July is a Pythagorean Day. Easy for me to say. So think of the date, 24th of July 2025. Try and think why that might have something to do with Pythagoras. But there's a link in the newsletter and some resources to go for that. Now, if you're listening to this from the Northern Hemisphere, the end of the academic year is rapidly approaching. Or if you're in Scotland or in an international school, you may have already broken up for the summer. But for those that still go on through July, what would you do during that very last lesson of the school year? Would you just carry on as normal with the next textbook exercise? Would you turn your back and allow the students to run wild? Would you just show a video or play some maths games or run a puzzle quiz? Well, I'd love to hear what you get up to, because it will give me some ideas for the end of term maths activities page. Now, I'm very keen that the ideas should be maths related, so I'm not one of these that would show the latest blockbuster movie in class. It needs to be a maths activity. I'm a bit of a stickler in that way, not wishing to waste time for maths learning. But I do believe the last lesson should be memorable, exciting and fun. So, in the newsletter, there is a link to my lifelong collection of ideas brought together on the end of term maths page. Okay, here is another for your repertoire of interesting stories that maths teachers can tell.
From the Roman era, 2nd to 4th centuries AD, archaeologists have unearthed over 100 hollow bronze objects, now called Roman dodecahedrons. Each has 12 pentagon-shaped faces, pierced by circular holes of varying sizes, and small knobs at each vertex. Found across Britain, France, Germany and Hungary, but never in Rome itself, their true function remains a tantalizing mystery. Theories range from ritual or magical items and surveying instruments to knitting aids, calendar devices or measures for pipes and shafts.
So, when you're teaching about the Platonic solids or 3D shapes, these dodecahedrons offer a real-world example that blends sort of mathematical elegance with a historical mystery. I find them fascinating, and your pupils may do too. Okay, so finally the answer to last month's puzzle, which was...
A rectangular jigsaw puzzle has 864 pieces. The number of pieces along its length and width have a lowest common multiple that is 6 times their highest common factor. How many pieces of the puzzle do not have any straight edges?
So I began with the prime factorisation of 864. So my scientific calculator does this very quickly, and I think all students should realise how they can use a scientific calculator to find the prime factors of a number. Very useful tool there. I could have done it obviously using one of the manual methods for finding the prime factors of a number, but anyway, for this particular instance, my calculator was the quickest way for me to do it. And then I drew a 2-set intersecting Venn diagram representing the length and the width. So one circle represents the length of the rectangle of the puzzle, the number of pieces, and the other circle represents the width, or the number of pieces of the puzzle in the width. And I assume that the length was the longer of the two. Obviously, it could be either way around, but I'll just go for that. So I did this because the product of the numbers in the intersection, or the factors that I've put in the intersection of this Venn diagram, represents the highest common factor, and the product of the numbers in the union of the two circles represents the lowest common multiple. And we're told that the lowest common multiple of the two numbers is 6 times as big as the highest common factor. So the numbers in the circles outside the intersection region must multiply together to give 6. And because they're prime numbers, there's just the 2 and the 3. So you could either put the 3 and the 2 in different areas, or you could put the 3 and the 2 together in the on the length side outside the intersection. So once I'd got this sorted out, I knew that I could multiply the numbers together in each circle to find the dimensions. So one solution was 36 and 24, and the other solution was 72 and 12. And then you do the bit where you have to subtract all the sides that have got straight sides, that's the edges. Careful you don't count the corners twice. And what's left is the final answer. So the answer is 748 if the dimensions were 36 and 24, or the other answer is 700 if the dimensions are 72 and 12. A lot easier to see written down rather than listen to me talk through it. So again, transom.org/newsletter, and you can see the Venn diagrams I created in order to get the answer.
Then the puzzle's been solved. The mystery ends. There's nothing too hard for Transom's great friends.
So this month, not everyone got the answer correct on their first attempt, but nevertheless I was delighted to receive the emails about the puzzle. And the first 5 people this month were Kevin, Chris, Marla, Alan and Esther. Well done to everybody that took part. That's always great to see. Okay, that's all for this podcast. Oh, apart from to say, what did the coordinates do at the greengrocer's? Ordered pears.
Thank you for downloading and listening to the Transum podcast. You can find the website at www.transum.org, where you're welcome to use all of the activities absolutely free. Or jump in with both feet and become a Transum subscriber.